Hello there. If you're a fan of the dungeon-crawling, dragon-slaying epic Skyrim, or if you're an Eskimo who lives at the North Pole and just so happens to have access to the internet, then you've probably seen something recently called the Northern Lights, or Aurora. Well, I'm going to try and give you a very brief, very interesting, I promise, and not too drunken, gamer's guide to how the Aurora work. Let's begin. We start with the sun, represented by this little orange ping pong ball. When the sun shines, it gives off billions and billions of tiny particles, mainly protons, called the solar wind. Think of it as a giant space fart. The Earth, represented by this blue ping pong ball, obviously goes round the sun, and some of that solar fart is pointed straight at the Earth. Now, as this fart travels through space, it eventually hits something called our magnetosphere. Now, contrary to common belief, the magnetosphere actually has nothing to do with the X-Men. The magnetosphere is actually a very simple thing. In school, did you ever drop iron filings around a bar magnet like this with a north and south pole? If you did, you'll remember that those iron filings congregated in this strange pattern. Scientists call this the magnetic field lines. Anything with a magnetic field has this. Now, if you own something like a compass, you may realise that the Earth too has a magnetic field. So it also has magnetic field lines. These magnetic field lines culminate or end at the northern and southern poles. Now, what happens is that as the sun shines on the Earth, the solar wind comes along and hits the magnetosphere, hits the magnetic field lines and is deflected, channelled mainly to the north and south poles. Now, something interesting happens in the atmosphere at the north and south poles that creates the shining effect, which is the northern and southern lights. What is that? I'll try and explain it, again using ping pong balls. Let's imagine now that the orange ping pong ball is the nucleus of an atom floating around carelessly in the atmosphere at the north or south pole. As this floats around in the top of the atmosphere, it also has an electron, which we're taught orbits the nucleus of an atom. But rather than orbiting it by swirling around it, the electrons sit in something called an allowed energy level. Think of it like placing it in a particular place where it's allowed to be. It can't be anywhere else. The top of this red test tube. Then, a very high energy particle from the sun comes along, as represented by the BB fired by this gun. Something like this happens. When I fired the BB at the electron, you'll note that it moved out of its allowed energy level and made a noise. Well, in a similar way, the electrons sat in their allowed energy levels get punched out by the incoming solar wind particles. And as they leave and are excited by these solar particles, they give off, rather than sound, a photon. And if that photon hits your eye, you see it as light. And that, ladies and gentlemen and gamers, is how the solar wind causes our aurora. Thanks for playing.